I need you to take out your tablet. We are going to we're going to set up our OneNote notebook for the semester. Yeah. Once you've opened your tablet, I need you guys to open up Microsoft Teams. Make sure it's the work or school version. So like if you just type Teams into the search bar at the bottom, should pop up. One of the options should be the work or school option. When Teams loads, you should see a tile for second hour pre-calculus. I loaded everybody in yesterday. Does anybody not see the tile? Yes. Work or school? All right. Once you stop talking, please. Once your Teams is open, go ahead and click on the second hour pre-calculus tile. On the navigation panel here on the left, find the place where it says Class Notebook. Click on that. Might take a minute, but OneNote should load into this panel here on the right. Up at the top where it says Editing, click the drop down there and then select Open in Desktop App. And that should open up the OneNote for you, and that'll be this semester's OneNote. Mary, what's up? What do you mean? Did you pick the work or school one? Yeah.
Your brother say easy?
Now, once you've got your new notebook opened, my suggestion to you would be to close your notebook from last semester. I've already closed out the notebooks on my end, but I know we've had syncing issues from people with open notebooks for inactive classes. So my suggestion to you would be to close out your old notebooks. Again, the way you do that is you just, from the drop down, you right click and then pick Close Notebook. I would close out last semester's notebook.
Yeah, we did just get back yesterday. It was, I think it was a half travel day. I'm sorry. Yeah. We're on the same side. It's okay. Do you have
Yes, you
Okay, perfect. Thank you. I have one too. To Mr. Smith. I don't want to go to my test. We all go.
That's so great.
I'm an hour
It's loading.
like 4,000.
I wish I missed some last time. I got so many points.
I think he likes
How'd you guys? Get it all squared?
Oh no, he just I'm not even wrong.
Yeah.
Everything she does, he thinks yeah, I'll be sitting there. I don't like taking notes. He's like, why are you sitting like that? Her problems, everyone's going on the phone. Oh, we always have to. Oh my God. I'll figure it out. I'm so happy for you. I'm just trying to get like.
All right. Syllabus. Everything is basically the same as last semester. So, Isaac, I would say that you should take some time and look through that. There is a sign-in sheet at the very end. I would like you to complete that. Everyone else that's already done that first semester, I don't need you to do it again. But the class will be the same kind of format as it was first semester. So no real surprises there. We're going to be starting with chapter 6 here, which is a continuation of looking at our trig identities that we talked about in the end of first semester. So if you remember, at the end of first semester, we talked about our basic trig identities. We did, some simplifying problems and some verifying problems and a little bit of solving. Here we're in this chapter 6, we're going to see some new sets of identities. We're going to see sum and difference and multiple angle, meaning double, and then power reducing and half angle identities. But I'm not going to ask you to do any simplifying or verifying or solving with this. We're just going to be using these identities to generate an exact answer for sine, cosine, tangent kind of problems. So we're going to be using these identities. So let's just see what's the best way to do this. Let's just grab this stuff. All right, so let's say that our direction says use our sum and difference identities to find the exact value for cosine of 75 degrees. Notice that 75 degrees is not a unit circle angle. Everybody agree with that? However, what I want to try to do is to break 75 up into either a sum or a difference, it doesn't matter which, of two unit circle angles. So let's go and look at our unit circle. Do you see two numbers or two unit circle angles that will add to give you 75? What would they be, Joey? You're shaking your head. Okay, let's use degrees, though, because we said 75 degrees. 45 degrees and 30 degrees. Great. That would work. Everybody okay there? Do you see two angles that we could subtract and get 75 degrees? Great, 120 minus 45 would give us 75. And in fact, there's lots of other answers to that, right? Like you could do 225 and, 210 and 135. And like you could, there's a whole mess of them, right? It doesn't matter. They're all going to come up with this, they're all going to evaluate out to the same answer. Now, which one of those was the easiest to see? Probably 30 plus 45, right? Everybody's okay with that? So that's what we're going to use. Is it going to matter if I did 30 plus 45 versus 45 plus 30? No, it'll end up being the same thing. Will not matter. So far, so good. Now what I'm going to do is I'm going to go to my angle sum or difference formula for cosine on my identity sheet. Which is that right there. So this is going to tell me that if x is 30 and y is 45, then I'm just going to be plugging those into my formula, right? Is everybody so far so good? So we have cosine of 30 times cosine 45 minus sine 30 times sine 45. So far, so good. Now what I want to do is evaluate each one of these trig expressions. So I'm going to go to my unit circle and find cosine of 30. So how do I use my unit circle to find cosine of 30 again? That is true, but that's not the one that I want. So I'm going to locate 30 degrees. And then on my unit circle, cosine is x, right? So cosine of 30 is root 3 over 2. Everybody happy? Okay.
Wait, does it matter when we choose our initial numbers?
Well, I'm doing cosine of 30.
Well, no, I'm saying like the first one. So to add them together, does it matter where we get them from or subtract them?
They have to be unit circle angles.
Well, yeah, but it doesn't matter what the quadrants.
No.
Okay.
As long as they add or subtract. I mean, you could have done, you could do 120 and negative 45.
Okay.
Right? Like if you wanted to do that, you could do that. 120 plus negative 45 is going to be 75. I don't know why you would want to, but yes, doesn't matter where you draw them from as long as they add to 75 or subtract to 75 and are coming from the unit circle. That'll all simplify down to the same thing. So there's cosine of 30. Now I need cosine of 45. Well, what do? I go back to my unit circle. 45 is here. Cosine is x, so that's going to be root 2 over 2. Everybody feel good? I'm going to fill this in from here, right? Sine of 30 degrees is 1/2. Sine 45 is root 2 over 2. All right, arithmetic review time. Root 3 over 2 times root 2 over 2. We're multiplying two fractions, correct? How do I multiply two fractions? You just do it. So straight across, top times top, bottom times bottom. Okay, well, how do I multiply root 3 times root 2? That's, I know, it's right, it's the beginning of the semester. So hopefully from Algebra 2, that looks familiar. The square root of a times the square root of b is just the square root of a times b. So that should be square root 6. And then 2 times 2 is 4. And then let's do the next pair of fractions. What's 1 times square root 2? Just square root 2. And 2 times 2 is 4. Now, to subtract these two fractions, what do we need? Common denominator. What do we have? Already have a common denominator. Great. How do I subtract square root 6 and square root 2 then? It's not square root 4. Yeah, you don't is the answer. You just write it as, because square root a minus square root b is not square root of a minus b. That's not true. And this would be our final answer. Does that feel okay there? This is essentially what we're going to be asking you to do in this chapter. This is the only skill I'm going to require from you guys, is to just be able to use the appropriate formula, which I'll tell you in the problem what to use, and then to grind through the answer. Let's do another example. Sound good? Come on. There we go. Let's make this a little bit more complicated. So use the sum and difference identities to find the exact value of sine of 5 pi over 12. What's going to make this harder? It's not in degrees, it's in radians. Yeah, that would be my suggestion to you, is convert that radian measure into degrees. What do I need to do to change 5 pi over 12 into degrees? Multiply by 180 over pi. So when we do that, let's see, the pi's cancel. 6 goes into, or I'm sorry, 6 goes into both of those. And then that. So 5 pi over 12 is really just 75 degrees. Now, just for the sake of argument, just to show you that it doesn't matter, instead of doing 30 plus 45 again, I'm going to do 120 minus 45. Just to do something different to show you that it's going to give you the same result, right? Since we did an addition problem previously, I'm going to do this as a subtraction problem this time. There's no reason you couldn't have done this as 30 plus 45, to be clear. I'm just kind of showing you what's going on, or that it doesn't really matter what's going on. All right, so we go here. Now we're using this one, right? So again, the x is like my 120 and the y is like my 45. I'm just going to plug those numbers now into my formula. Everybody feel good? Now I'm just going to evaluate each of these 4 trig expressions. How am I going to do that? Going to the unit circle, right? So I go to 120. So sine of 120 is the y coordinate. Cosine of 120 is the x coordinate. And then I do the same thing for 45. I'm just going to write that in instead of looking it up. Oops. Some minus 1/2. Does everybody feel okay? Now, just like before, I do my multiplication. I notice that I have minus and negative. What does that really mean? Just adding, right? And I have a common denominator, but just like before, I know I can't add those two radicals together because they are different radicals. So I just write them adding over the same common denominator, I'm done. Everybody feel okay there? It's okay. Really, we're not doing much different than what we did first semester, right? It just, okay, it's a new formula. Okay, it's going to allow me to find the exact value of angles that aren't exactly on my unit circle, but I can write as the sum or difference of angles from my unit circle. The other thing that we could do with this is I could ask you to do one of these. So I could ask you to write something as a single trig expression. So I notice here that, well, the 47 is repeated, and then that 23 is repeated. So if I think about that as like my x, and I think about that as my y, this is really like sine x times cosine y minus cosine x times sine y. So I'm just going to go to my identities and see, okay, is this like the sum or difference of sine or cosine or tangent? We're like, which one of the identities is this that's going on here? So if I look at my identities, that looks like this, right? Sine x times cosine y minus cosine x times sine y. Everybody agree with that? So, that told me it was the angle difference formula. So just sine 24. Everybody okay with that kind of idea, that kind of problem? Not a big deal, right? Hopefully that feels pretty comfortable. Yes, of course. Okay. Let's see. That looks good. Okay. So maybe we do the same kind of thing here and we ask, okay, use the power reducing identities to find the exact value of something, and maybe we give you like sine squared equals 3 pi over 8. So what I'm going to do is I'm going to go look at my power reducing identities on my sheet. So that's these ones right here. And I'm going to be looking at the one for sine squared. So I'm going to rewrite that as 1 minus cosine of 2x divided by 2. Now my x in this case is 3 pi over 8. So I have that. So far, so good? Yes, of course. I understand. So far, so good? We're okay with how I plugged that in? That's the first part I want to do. What is 2 times 3 pi over 8? 6 pi over 8, or reduce this down to 3 pi over 4. So again, the way I would think about it is like reducing that way. Okay. Now I'm going to go to my unit circle and find the cosine of 3 pi over 4. What happens if I can't, if the angle that I find isn't on my unit circle? Means you've made a mistake. Okay, the questions I'm going to give you, after you do this, you should have a unit circle angle, right? If you didn't, then you've done something wrong. So cosine of 3 pi over 4 is just negative root 2 over 2. Looked it up off the unit circle. I notice I have minus a negative, so that's going to mean addition. But I kind of hate this like fraction inside a fraction thing I got going on here, right? So I'm going to try to simplify this and just make it into like a simple fraction rather than this fraction inside a fraction thing. The easiest way to do that is going to be to multiply the top and bottom of the fraction by the denominator of the little fraction on the inside. So I'm just going to multiply the top and bottom by 2. So in the numerator, that 2 distributes through. 2 times 1 is 2. And then 2 times root 2 over 2 is just root 2, right? These really had like a 2 root 2 over 2, and those reduced down. So my answer should be 2 plus root 2 over 4. Is that okay? Again, shouldn't be too complicated here. Let's do something kind of sneaky though. Yeah. What if we had given you what if I give you cotangent squared of negative 165 degrees? Supposed to be using power reducings. Okay, well, let's go look at the power reducing. Oh no, Mr. Kulik. Cotangent squared isn't, I don't have a power reducing formula for that. What do I do? Yeah. So it just should be the reciprocal of the tangent formula, right? Everybody's okay with that idea? What would I do if I had secant squared? The reciprocal of cosine. If I have cosecant squared, I do the reciprocal of sine, right? No problem. But I just need to remind you guys that that's why we don't have 6 formulas. 3 is fine, because all the reciprocal ones are just reciprocals. Okay. Let's finish this out then. So we're going to have 1 plus cosine of 2 times negative 165 over 1 minus cosine 2 times negative 165. Again, first thing I want to do is that multiply by 2 part. 2 times 165 is 330. So I have negative 330. Now here I have 2 options. What I would suggest to you is notice negative 330, that we don't have any negative values on our unit circle. Oh no, what do I do? Add 360. Just find something coterminal to it. Absolutely. That's the way I would handle that. Everybody feel good there? Okay, when I go to my unit circle and I look up cosine of 30, I have that's root 3 over 2. So far, so good. What don't I like about this answer, though? Yeah, I have that fraction inside a fraction. How do I get rid of it? Yeah, multiply the top and bottom by 2. Yep. That's exactly right. That's exactly what I'm choosing to do. Oops. So I have that. That's better, right? Because I don't have fraction inside a fraction. What do I have a problem, though, with this? What's still a problem here? What don't I like about this answer? We have a square root in the denominator. It's a tough question I'm about to ask. Who remembers how to get rid of that? So we're going to multiply by something. That's good. What is that something? By square root 3? That's not going to do it. Because when we do that, it's going to distribute, so I'm still going to end up with a square root of 3 stuck to that guy. Close. It's the conjugate. So just the same thing with the different sign in the middle. Hey, ladies, can we please stop talking? Okay. You guys vaguely remember that from Algebra 2 or maybe even geometry? It might have been that you would have talked about it. Now here's the hassle. So you have to FOIL that out. Here, I noticed that that's like a difference of 2 squares factoring pattern, like a minus b times a plus b. You guys see that? So that I can do in my head because it's just going to be, when I multiply that out, I'm just going to get 2 squared minus root 3 squared. But the top I have to like FOIL. Is that okay? All right, so let's do some simplifying. 2 squared is 4. What is root 3 squared? Just 3, right? Goodness gracious. So I have 4 plus 3, that's 7. And then those guys, you can combine. Those are like terms. 2 root 3 plus 2 root 3 plus 2 root 3 is how many root 3s? 4 root 3s. So that just becomes 1 down there, and I'm just going to drop it. So 7 plus 4 root 3. Everybody feel okay there? Let's stop here. For homework, I'd like for you guys to work on 1 through 10. That's enough for right now.
Is that due Sunday?
Nothing due Sunday. What's up? I don't know. No?